Welcome back to Chemistry Lab. Today's topic, the chemistry of art. Art and chemistry have an interwoven history going back to the creation of some of the earliest forms of art, cave drawings from some 40,000 years ago. In the lab, we are going to synthesize two different pigments, Prussian blue and barium white. We will try painting with our new pigments, and we will look at the optical properties of these pigments by looking at how they absorb visible light with a spectrometer. Pigments are made of different types of chemical compounds. We have metal salts, such as the barium sulfate, which is referred to as barium white, that we'll be making today. There are organic compounds that produce pigments. You can think a lot of these as different types of plant extracts, for example. A third type that we'll look at today that includes Prussian blue is a coordination complex. A coordination complex contains something called a coordinate bond. For example, if we look at ammonia, a Lewis dot structure for ammonia, we have this. The ammonium ion is this structure with an extra hydrogen added. The electrons in the bond for the extra hydrogen both come from the nitrogen. So this one is referred to as a coordinate covalent bond. In the structure of Prussian blue, we have the same thing going on with iron and a cyanide type complex. Cyanide has a Lewis dot structure that looks like this. The coordinate covalent bond here is the bond of iron to the carbon of the cyanide ion. The electrons of the carbon are the electrons in this bond. I hope you enjoy making pigments in lab today and looking at them through the lens of chemistry. Don't forget to answer the pre-lab questions and have a great lab.